Hello friends, my name is Nilkant Mohite. In today's lecture we are going to learn Engineering Mechanics Chapter 6 Kinetics of Particles. Today we are going to take a problem on work done by spring force. A smooth 10 Newton collar C fits loosely on the horizontal shaft as shown in figure. If the spring is unstretched at x is equal to 0, the collar is given an initial velocity of 4.5 meter per second. Determine the velocity of collar when x is equal to 1 meter and also find the value of x at which velocity of collar becomes 0. Let's see the figure. We have seen one spring is attached at point B to point C. C is the collar which is attached on shaft. It can be easily slide on the shaft. Spring attached between B and C which is in its initial position means what? There is no any extra forces on the spring. Spring is not stretched or compressed, which is in initial position only. In that problem, the collar velocity is given. Its initial velocity is 4.5 meter per second. 4.5 मीटर पर सेकंड ये वेलोसिटी से वो मूव कर रहा है टूवर्ड्स पॉइंट ए और डी. डिटरमाइन द वेलोसिटी ऑफ कॉलर व्हेन x इज इक्वल टू 1 मीटर. मीन्स हमें x की वैल्यू जब 1 मीटर रहेगी, मतलब c कॉलर 1 मीटर ट्रैवल करेगा तब जाके वो ए पॉइंट पे आएगा. तो वहाँ की वेलोसिटी पूछी है. also find the value of x at which velocity of collar becomes 0. मीन्स कॉलर वहाँ तक ट्रैवल करेगा, एक पॉइंट आएगा जब उसकी वेलोसिटी 0 हो जाएगी. तो वो वेलोसिटी 0 होने तक कितना डिस्टेंस ट्रैवल करना है ये हमें निकालना है. लेट्स स्टार्ट द प्रॉब्लम. स्टेप 1, फोर्सेस एक्टिंग ऑन द कॉलर विच कैन डू वर्क. स्प्रिंग फोर्स मतलब कौन से फोर्स एक्ट हो रहे हैं यहाँ सिर्फ स्प्रिंग फोर्स एक्ट हो रहा है. नाउ स्टेप 2, डायग्राम ऑफ द सिस्टम. लेट्स इमेजिन द डायग्राम. व्हेन C collar travels towards A, it travels 1 meter distance with initial velocity 4.5 meter per second and distance between B to C is 1 meter, and we have to calculate velocity at point A. Now step 3, using work energy principle from point C to from point A. In between point C to point A, it travels x distance, and we have to use work energy principle in that points. We know the work energy principle. Difference in kinetic energy is equal to work done. Kinetic energy at point A minus kinetic energy at point C is equal to work done between point C to A. It is denoted as US. Kinetic energy at point A is equal to 1/2 mv square. Velocity at point A, that's why it is denoted as VA square. Put the value of mass and velocity, we get the answer. Kinetic energy at point A is equal to 0.51 VA square joule. Here velocity at point A we have to calculate. Second is kinetic energy at point C is equal to half into mvc square, mass into velocity at point C, which is known 4.5 meter per second. Put the value of mass and velocity, we get the answer 10.32 joule. Now work done by spring, we know the formula for work done for spring. अब हमें पॉइंट सी टू पॉइंट ए उसमें कितना वर्क डन हुआ ये निकालना है. यू एस इज इक्वल टू के डिवाइडेड बाई 2 इंटू x1 square minus x2 square. Now what is K? K is given in problem, which is stiffness of spring 2 Newton per meter. x1 is equal to L1 minus L0. What is L1? L1 is the spring length of first position at point C, and L0 is the initial position which is also at point C. Now we know the value of both L1 and L0. It is 1 meter. That's why we get the value of x1 is 1 minus 1, 0. Now x2 is equal to L2 minus L0. L2 is a string length of second position which is at point A. L2 is equal to, we can calculate by diagonal theorem. We get the value of L2 is 1.414 meter. Now x2 is equal to 1.414 minus 1 meter is equal to 0.414 meter. Now we know all the values of work done by spring formula. K stiffness we know, x1 is calculated, x2 is calculated. Now put this value in equation, we get US is equal to K divided by 2 in bracket x1 square minus x2 square. US is equal to, put the value of K is 2 divided by 2 into in bracket x1 is 0, that's why 0 minus 0.414 square, we get the value of work done minus 0.171 joule. Now we have the value of work done and we have calculated kinetic energy at point C and kinetic energy at point A. Now put this all value in equation, which is work energy principle. Kinetic energy at point A minus kinetic energy at point C is equal to work done. Put the value, we get value of unknown, which is velocity at point A is equal to 4.46 meter per second. This is our first answer. Now step 4 is to find value of x when velocity at 0. This is the second condition, which is point at A, velocity get 0, means how much distance travel by color when it's get velocity 0. Consider velocity is 0, that point is A. Then again we are using work energy principle from point C to point A, which is kinetic energy at point A minus kinetic energy at point C is equal to work done between point C to A. Calculate the kinetic energy at point A. We know the formula, which is 1/2 mv square. Now we know the velocity at point A is 0. Put the value of mass and velocity. Velocity which is given in second condition, and what is mass? Mass is weight upon gravity, which is 10 Newton divided by 9.81. But velocity is 0, that's why we get the kinetic energy at point A is 0. Now find the kinetic energy at point C is equal to 1/2 mv square. Put the value of mass and velocity at point C, which is given 4.5 Newton per meter. we get the value of kinetic energy at point C is equal to 10.32 joule. Now we know the formula for work done. US is equal to K divided by 2 into x1 square minus x2 square. Find the value of x1. X1 is L1 minus L0, means L1 is the length of spring at first position and L0 is the length of spring at initial position. X1 we get the value is 0 because L1 is 1 meter and L0 is 1 meter. Now calculate the x2. x2 is equal to L2 minus L0. L2 is length of spring at second position and L0 is length of spring at initial position. By diagonal theorem we know the value of L2, which is under root 1 square plus x square minus L0 is 1 meter. Now put this value in work done formula. US is equal to 2 divided by 2 in bracket 0 minus under root 1 plus x square minus 1 bracket complete square. 2 gets cancel minus in bracket under root 1 plus x square minus 1 bracket square. In left hand side, kinetic energy at point A minus kinetic energy at point C is 0 minus 10.32. Now in next step we are going to taking square roots at both the side. We get under root 1 plus x square minus 1 is equal to 3.212. Minus 1 will move on right side and get plus 1. Then next step is under root 1 plus x square is equal to 4.212. Again taking square of both side, 1 plus x square is equal to 17.74. Now we can easily get the value of x is 4.092 meter. This is the second solution. Collar travels distance 4.092 meter and reach at point A where its velocity is 0. Here is this end of problem. Friends, if any queries, please comment in below. Thank you.